Hey, this is Mr. K, and today we're going to go over derivative notation as well as the power rule for derivatives. So first, you can see on my paper here I have at least 4 different ways of writing like, hey, find the derivative. So like if question asks you to find f prime of x, that's a derivative. If it says find dy dx, that's a derivative. And if you're wondering like how come this is a derivative, a way that I always think of like the letter d there is change. So if it's the change in y divided by the change in x, that's slope. And in a previous video we talked about how a derivative like that mean that gives you the slope of the curve or the slope of the tangent or the instantaneous speed or instantaneous rate of change. So that's all of those things. You'll also see d and then d dx. With this, typically when this will follow, or this will be followed by like an equation, which means it's taking the change in this equation, which is like your y value, divided by the change in x. So it's still asking you to find the derivative just of the equation that should be following right after this notation. Or a question might just say to differentiate, in which case it's saying find the derivative. So now what the power rule is, it's saying that if I have an equation, we'll say f of x equals x to the n power. What you can do then is for your derivative, you basically bring this exponent out in front, so you're going to multiply by your exponent, and then you are going to subtract 1 from your exponent. That's how the rule is written. It's also written that x cannot be 0, and it's also written that n needs to be a positive integer, but that's technically, like, it's true, but if n was a negative integer, the only thing that happens is that a negative is going to come out here, and it's going to change things just a little bit, but we'll cover that in a separate video. One other thing I forgot to mention is also for second derivatives, because there's second, third, fourth derivatives. You can keep taking derivatives. So like if I wanted to do the second derivative here, there would just be 2 primes instead of 1 prime. And then for dy dx, it'd be written as dy, and then it'll look like squared over, actually it would be, my bad, it'll be d squared y divided by dx squared. So that's just a different way of writing the second derivative. But typically, like I'd say most of the time, you're going to see it as like f double prime of x. So let's get an example here of an equation. So like let's say that I have, let's say my equation is, we'll just say 3x to the 5th. So then if I wanted to find the derivative of that, I would multiply by my exponent. So like I'm going to take this 3, multiply it by 5, and I'll get 15. And that'll be x to the 4th power. That's it, done. And so now what you can do is if, let's say it said find the slope of the tangent at x equals 5. All you need to do is substitute a 5 into your derivative function, and that will get you the slope of the tangent at that spot. So it makes it a lot easier finding the slope of the tangent versus using the limit definition, which is much more time consuming. If I give a different equation here, so now let's say that our equation is 3x squared minus 5x plus 2. If I wanted to find the derivative for this function, what you can do is you can separate this into 3 different separate problems, just like we did with limits, where if this was the limit as x approaches 0 of these 3 things, you could just separate them into 3 separate limits. So when I take the derivative of the first part of this, I'm going to multiply by 2 out front, so I'll have 3 times 2, which is 6, and then it's going to be x to the 1 power, or you can just leave it as 6x. Here, since there's like a 1 as the exponent there, I'm going to multiply by 1, and so 5 times 1 is just 5. And now this, since I'm going to subtract 1 from the exponent, this will be like x to the 0. But recall that anything to the 0 power is just 1. So we'll keep that in mind for later. But then also right here, there are no x's. So technically it's like x to the 0. So now if I'm going to multiply by my exponent, I'm going to get 0 times 2, which is just 0. And then it doesn't matter, this whole thing is just going to become 0, which makes sense because think about what the plus 2 does to the picture. The plus 2 just takes the graph and moves it up 2. It doesn't affect the slope at all. And remember that our derivative is like an equation that represents the slope of this curve. So because this doesn't affect the slope at all, it shouldn't be part of my derivative. So that's why it makes sense that this becomes 0 and it's not going to be part of our derivative. So our final answer for our derivative function would be 6x minus 5. And so that's how you can use the power rule to find the derivative of a function. Thanks and have a great day.